Another special real number is pi over 3. Pi over 3 is equal to 60 degrees. To determine the coordinates of this point, we draw a line from this point downward. So we have a 30 by 60 by 90 degree right triangle. This side is x, y, and 1. Recall that in a 30 by 60 by 90 degree right triangle, the side opposite the 30 degree angle is always 1/2 the length of the hypotenuse. In this case, the opposite side of 30 degree is x. Thus, x is equal to 1/2. To solve for y, we then again use the equation of unit circle and replace x with 1/2 and simplify. 1/2 squared is 1/4. Then, transpose 1/4 to the right side and simplify. 1 minus 1/4 is 3/4. Square root of 3 over 4 is square root of 3 over 2. Thus, y is equal to square root of 3 over 2. So the coordinates of pi over 3 are 1/2 and square root of 3 over 2. To identify the multiples of pi over 3, we first need to divide the circle by 60 degrees. So 360 divided by 60 is equal to 6. We now have here 1 pi over 3. The second point is located here. Then the third, fourth, fifth, and sixth. And these points are the multiples of pi over 3. If this is 1 pi over 3, this point is 2 pi over 3. Next, this is 3 pi over 3 or pi, followed by 4 pi over 3, then 5 pi over 3, and the last point, which is 6 pi over 3 or 2 pi. So the coordinates of 2 pi over 3, 4 pi over 3, and 5 pi over 3 are the same with the coordinates of pi over 3. Nag-iiba lamang sa sign. Here, the x value is negative, while y is positive. While 4 pi over 3, the sign of x and y are both negative. And 5 pi over 3, x is positive while y is negative. Examples. Find the values of the following. These are all multiples of pi over 3. So we're gonna use these values. Letter A, sine 4 pi over 3 is equal to negative square root of 3 over 2. 4 pi over 3 is located here with coordinates negative 1/2 and negative square root of 3 over 2. Sine is equal to y. Thus, sine 4 pi over 3 is equal to negative square root of 3 over 2. Cosine 5 pi over 3 is equal to 1/2. This is 0.5 pi over 3. Cosine is equal to x, and the value of x in here is 1/2. Then, cotangent negative 7 pi over 3. Since this is negative, we count 7 times in a clockwise direction. We start with this point, so this is negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3, and negative 7 pi over 3. It coincides with 0.5 pi over 3. So we're gonna use these coordinates. Cotangent is equal to x over y, where x is 1/2 while y is negative square root of 3 over 2. And this is equal to 1/2 times negative 2 over square root of 3, the reciprocal of the denominator. 1 times negative 2 is negative 2, over 2 times square root of 3 is 2 square root of 3. Cancel out 2, we get negative 1 over square root of 3. Rationalize the denominator, we have negative square root of 3 over 3. Negative 1 times square root of 3 is negative square root of 3 over 3. We cross out the radical sign and copy the radicand 3. Thus, cotangent negative 7 pi over 3 is equal to negative square root of 3 over 3. Letter D, find cosecant negative 11 pi over 3. Count 11 times clockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It coincides with pi over 3. Cosecant is equal to 1 over y, and y value is equal to square root of 3 over 2. So 1 over square root of 3 over 2 is equal to 1 times 2 over square root of 3. 1 times 2 over square root of 3 is 2 over square root of 3. Rationalize, we have 2 square root of 3 over 3. 2 times square root of 3 is 2 square root of 3 over 3. And these are the trigonometric points corresponding to pi over 3 and its multiples. The last type of special real numbers is pi over 4. Pi over 4 is equal to 45 degrees. To determine its coordinates, we draw a straight line to form a right triangle. This angle also measures 45 degrees. We have an isosceles triangle where the two sides are equal. So x and y are equal. The equation of the unit circle will be x squared plus x squared equals 1, since we let x be equal to y or y be equal to x. X squared plus x squared is 2x squared equals 1. Divide by 2, we have x squared equals 1/2. Take the square root of 1/2 and that is equal to square root of 2 over 2. So x is equal to square root of 2 over 2. But since x and y are equal, y is also equal to square root of 2 over 2. Hence, the coordinates of pi over 4 are square root of 2 over 2 and square root of 2 over 2. To determine the multiples of pi over 4, divide the circle by 45 and that is equal to 8. 4 parts above and below. We already have here 1 pi over 4, so the second point is located here. Then the third point, 4th, 5th, 6th, 7th, and 8th. And these points are the multiples of pi over 4. This is 1 pi over 4, 2 pi over 4, or pi over 2. So this point is 3 pi over 4. Then 4 pi over 4 or pi. So this is 5 pi over 4. Next is 6 pi over 4 or 3 pi over 2. Followed by 7 pi over 4. And finally, this point is 8 pi over 4 or 2 pi. The coordinates of these multiples are also square root of 2 over 2, square root of 2 over 2, that differ only in sign. Since this point is located on the second quadrant, x is negative, y is positive. This point is located on the third quadrant, so x and y are negative. While this point is on the fourth quadrant, thus x is positive while y is negative. Examples. Find the values of the following. Cosine 3 pi over 4, which is this point, and cosine is equal to x. The x-coordinate is negative square root of 2 over 2. Thus, cosine 3 pi over 4 is negative square root of 2 over 2. Letter B, sine 5 pi over 4. Sine is equal to y, and 0.5 pi over 4 is located here. The y value is equal to negative square root of 2 over 2. Next, cotangent negative 7 pi over 4. It is negative, so we start with this point and count 7 times in a clockwise direction. 1, 2, 3, 4, 5, 6, 7. It coincides with this point, and cotangent is equal to x over y, or square root of 2 over 2 over square root of 2 over 2, which is equal to 1. D. Cosecant negative 9 pi over 4. This point is already negative 7 pi over 4, so this point is negative 8 pi over 4, then negative 9 pi over 4. It coincides with point 7 pi over 4. Cosecant is equal to 1 over y. The y value here is negative square root of 2 over 2. So 1 over negative square root of 2 over 2 is equal to 1 times negative 2 over square root of 2. 1 times negative 2 is negative 2 over square root of 2. Rationalize, we multiply the numerator and denominator by square root of 2. Negative 2 times square root of 2 is negative 2 square root of 2 over square root of 2 times square root of 2 is 2. Square root of 4 is 2. We cross out 2, hence this is equal to negative square root of 2. And so these are the trigonometric points corresponding to pi over 4 and its multiples. Here's the summary of the coordinates of the points corresponding to arcs whose lengths are multiples of the special real numbers pi over 6, pi over 4, and pi over 3. This is what we called the unit circle. For non-special real values, the values of circular functions can be determined by using a scientific calculator.